Hi everyone, today we're going to go over lesson 4-6, which is the quadratic formula and the discriminant. As always, pause the video as needed to work on problems or to take more time to write notes. So the quadratic formula is something you should have gone over in Algebra 1, and it's the formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is when we're using standard form, which is ax squared plus bx plus c. So the biggest thing here is to make sure that you do have it in standard form, that a doesn't equal 0, and then you identify a, b, and c and plug it in. So in the example, we have x squared plus 5x plus 6 equals 0. A is 1, b is 5, c is 6, and you go ahead and plug it in, and then you can simplify and solve for x. So we're going to take a look at an answer that has two rational roots. So we have x squared minus 8x plus 33, or equals 33. So the first thing we need to go ahead and do is actually change the format so that it's in ax squared plus bx plus c form. This is also known as standard form. So we're going to do that by subtracting 33 from both sides. And then once we have a, b, and c, which are the coefficients or the constant, we do not include x squared or x when we're identifying a, b, and c. We're only looking at the coefficients and the constant, which is c. And we're going to substitute these values into our formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So on the previous slide, we identified a is 1, b is negative 8, and c is negative 33. So we substitute these values in. And we're going to head and simplify so that we have positive 8 plus or minus the square root of 64 plus 132 all over 2. So we're going to simplify again to get 8 plus or minus the square root of 196 over 2. 196 is a perfect square of 14, so we have 8 plus or minus 14 over 2. And the whole reason we are having plus and minus here is, again, that I could multiply positive 14 times positive 14 or negative 14 times negative 14. So that's where we get our plus or minus, and these would both equal 196. So we're going to go ahead and do that. So we have our two equations, 8 plus 14 over 2 and 8 minus 14 over 2. We're going to go ahead and simplify to 11 and negative 3. So our solutions are 11 and negative 3. Go ahead and try solving x squared plus 13x equals 30 by using the quadratic formula. I'll give you a moment to pause the video. All right, let's take a look here. We're going to go ahead and subtract 30 from both sides. That way we can get it into standard form so that we have x squared plus 13x minus 30 equals 0. We're then going to identify a, b, and c. So we see that a is 1 because that's my coefficient of x squared. B is 13 because that is my coefficient of x. And c is negative 30 because that is my constant. It does not have a variable. So we're going to go ahead and plug this into our formula. We have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is in 1. So sorry about that. So we're going to go ahead and simplify. We get negative 13 plus or minus the square root of 169 plus 120. Because negative 4 times negative 30 is positive 120 all over 2. So we're going to go ahead and simplify again. So we have negative 13 plus or minus the square root of, so we're going to add 169 and 120. 9, 8, 289. Which also happens to be a perfect square, which is really nice. All over 2. 289 is the perfect square of 17 and negative 17. So negative 13 plus or minus 17 all over 2. So we're going to get 2 options. We're going to do negative 13 plus 17 over 2 and negative 13 minus 17 over 2. So negative 13 plus 17 is positive 4. So we get 4 over 2, which is 2. And then negative 13 minus 17 is negative 30 over 2, which is negative 13. Or 15, I'm sorry. So our answer here is B. And take a look at example 2. We're going to go ahead and solve x squared minus 34x plus 289 equals 0 using the quadratic formula. We're going to have one rational root. What that really means is that when we were to graph this, wherever it might be, we'd only touch once, and that our vertex would be on the x-axis. So it's either going to open up or down based on your a value. But let's go ahead and take a look here. It is already in standard form, so that does help us out. And so our a value is 1, our b value is negative 34, and our c value is 289. So we're going to head and substitute those values in and simplify. So we get x equals 34 plus or minus the square root of 0 over 2. And that's because 34 squared is the same thing as 4 times 1 times 289. So when we simplify, we get 34 over 2, which is just 17. So we only have one solution, which is at x equals 17. And you can, of course, check by graphing. All right, so let's go ahead and try solve x squared minus 22x plus 121 equals 0 by using the quadratic formula. All right, let's go ahead and take a look here. So a is 1, b is negative 22, c is 121. So I'm going to do negative, or x equals negative b, so negative 22, plus or minus the square root of negative 22 squared. It's always good practice, especially when you're working with negatives, to put them in parentheses, because if you type in negative 22 without parentheses in the calculator, generally it's going to give you the wrong answer. So it's good to always have parentheses. And we're going to do minus 4 times a times c all over 2 times a, which is 1. And then we're going to go ahead and simplify. We get x equals positive 22 plus or minus the square root of 484 minus 484. So 22 squared is 484. 4 times 121 is 484. And dividing by 2. This ends up being square root of 0, and square root of 0 equals 0. So this is 22 plus or minus 0. which doesn't change anything. So this is just x equals 22 over 2, which simplifies to just 11. So our answer is A. All right, for our next example, we're going to look at irrational roots. So we're going to have solve x squared minus 6x plus 2 equals 0 using the quadratic formula. So we're going to go ahead and use 1 for A, -6 for B, and 2 for C. And we're going to substitute those values in and simplify to get 6 plus or minus the square root of 28 over 2. So this is irrational because this is not a perfect square, so we're going to end up with a radical in our answer. And if they ask you to estimate, you will have a rounded decimal. So we're going to head and simplify this to best abilities, and we get 2 squared root of 7 for our simplifying our radical, because 4 times 7 is 28, so and the square root of 4 is 2. So we get x plus 2 square root of 7 over 2 and 6 minus 2 square root of 7 over 2. So we are able to simplify this to 3 plus square root of 7 and 3 minus square root of 7. And I'm going to show you, we're only able to do that because when we're looking, the 6 is divisible by 2, and the 2 is divisible by 2, and 2 is divisible by 2. So we can actually simplify all 3 of these by dividing by 2. If not all 3 of these values outside of the square root are divisible by the same number, you can't simplify. So we get about the approximate solutions are 0.4 and 5.6. Depending on if they want you to round or not, but the exact solutions are 3 plus square root of 7 and 3 minus square root of 7. And of course, you can check that the estimations by graphing. All right, go ahead and solve x squared minus 5x plus 3 equals 0 using the quadratic formula. All right, let's take a look here. So we have A is 1, B is -5, and C is 3. You are going to have times when A is not 1. It just so happens all these examples so far have been. So we're going to head and plug this into our formula. X equals -b, so -5, plus or minus the square root of b squared, so -5 squared, minus 4 times A times C. All over 2 times A, which is 1. We're going to go ahead and simplify. -5 is +5, plus or minus the square root of 25 minus 12, all over 2. And this is the same thing as 5 plus or minus the square root of 13, all over 2. And that's actually all we're able to do. So that is our answer. And so we get D. All right, let's take a look at example 4. We have complex roots. So we did go over complex roots in 4-4, and that basically means that we're going to have imaginary roots. So I is going to be part of our answer. So let's go ahead and take a look here. This is not in standard form, so we need to go ahead and get it into standard form. So we're going to subtract 6x from both sides to rewrite this as x squared minus 6x plus 13 equals 0. And that's why they have b is -6 here, because they went ahead and moved over the -6 to the 6x to the other side. Then we're going to substitute our values in with 1, -6, and 13. They simplify to get 6 plus or minus the square root of -16 over 2, which simplifies to 6 plus or minus 4i over 2, because the square root of -16 can be written as -1 times 16. So So 16 and square root of -1. And as we know, the square root of -1 equals I. And so they're able to use the bolded I when we write. We tend to write the curly bracket, the curly I. And so we can divide our coefficients and constants by 2 to get 3 plus or minus I. So our solution is 3 plus 2I and 3 minus 2I. So when you graph it, this basically means that you're not going to be able to graph this one to get the answer to double check it because of it having complex roots. The roots are imaginary, meaning they do not touch the x-axis. And so as they say here, a graph of the function does not shows that the solutions are complex, but it cannot help you find them. To check it, you would have to plug them into the original equation and check and see if you get equal solutions. And in this case, they do. You get 18 plus 12i on both sides. So go ahead and try x squared plus 5 equals 4x by using the quadratic formula. All right, let's go ahead and take a look at this one. The first thing we need to go ahead and do is subtract 4x from both sides to get x squared minus 4x plus 5 equals 0. We want it in standard form. So a here is 1, b is -4, and c is 5. So we're going to get x equals -b plus or minus the square root of b squared minus 4 times 1 times 5 all over 2 times a, which is 1. So we're going to head and simplify this. We get +4 because 2 negatives make a positive. -4 squared is 16. -4 times 1 times 5 is -20. All over 2. So this will simplify to 4 plus or minus the square root of -4 all over 2. And the square root of -4 is 2i. So we're going to get x equals 4 plus or minus 2i all over 2. All our coefficients and constants are divisible by 2, so we can go ahead and do that. And we get 2 plus or minus I. So our answer is A. All right, taking a look at the discriminant. So the discriminant is from the quadratic formula, and in the quadratic formula we have -b plus or minus the square root of b squared minus 4ac all over 2a. So the discriminant is what's inside the square root, which is really helpful for us. That's what can tell us several things about it. So when the value of the discriminant equals 0, where we are, here we are. So we'll start here. When the value is, how should we say this? When the inside of the root is positive, we have 2 rational answers, and when it's a perfect square, we have 2 rational. When it's positive and not a perfect square, so I'm going to put a square, and it's positive and it's not perfect square, we have 2 irrational. So you're going to have a square root in your answer. When the square root is 0, we have 1 root. When the square root is negative, we have 2 complex roots, meaning it's never going to touch the x-axis. This is just really good information to have if you're trying to check certain information, or if they're just asking you, what kind of roots do you have? If they're just asking the type of roots, you don't actually have to go through solving everything. You just have to say, well, there's 2 real roots, and it's rational or irrational, or there's only 1 root, or there's no real roots, is what we'll be looking at. So here we have a describing the roots. So find the value of the discriminant for x squared plus 3x plus 5 equals 0, and describe the number and type of roots. So they're not actually looking for the answer. They're just looking to say, do you have a real root? Do you have complex roots? How many do you have is what we're looking for. So we're going to take a look at A, B, and C. A is 1, B is 3, C is 5. And the discriminant is, again, b squared minus 4ac. So we're going to substitute our values in. We get 9 minus 20, which gets us negative 11. Because my answer is negative, I know I have 2 complex roots. And there's that one. Taking a look at this next example, we're going to do the same thing. Identify A, B, and C and plug into the discriminant. So we have negative 11 squared minus 4 times 1 times 10. So I get 121 minus 40. This equals 81. 81 is positive and a perfect square. So that tells us we have 2 rational roots. The moment you say you have 2 rational roots, it's assumed that they are real and you don't have to worry about identifying that. So go ahead and identify the number of roots and the type of roots for the equation x squared plus 8x plus 16 by using the discriminant. All right, let's take a look here. So we're going to use again b squared minus 4ac. So we have a is 1, b is 8, and c is 16. So we're going to do 8 squared minus 4 times 1 times 16. So we get 64 minus 64, which equals 0. So I have 1 real root, or 1 rational root. So in this case, our answer is A. All right, go ahead and find the value of the discriminant for x squared plus 2x plus 7 equals 0, and then describe the number and type of roots for the equation. All right, let's take a look here. We have, again, so we're going to identify A is 1, B is 2, and C is 7. So we're going to do b squared minus 4 times a times c. So I get 4 minus 28, which gets us negative 24. And that gets us 2 complex roots. So our answer is D. Just a quick summary of solving quadratic equations of the methods that we have gone over. So the first method we went over was graphing, and this usually works if you have real roots, but it can also not be helpful if you don't have exact roots where you have to use a decimal. So this is sometimes good, sometimes not good, but it's usually good to check your reasonableness of your answers. Factoring sometimes works because, again, sometimes we're not going to be able to factor depending on what we have. But you can use it, and sometimes it's a little bit more work. We also have the square root property, works sometimes because, again, it depends on if you're able to make that perfect square. Sometimes you have to do more work than you should. Completing the square will always work because you're setting it up so that you do get a perfect square to solve for. And then quadratic formula will always work. And sometimes it might just be easier to do that one depending on what options you do have. So they say sometimes when other methods fail or are too tedious, a good fallback is the quadratic formula. That is the end of our lesson, and I will see you next time when we go over 4-7. Have a good day.